So what question was it? Want to paste it in?
Yeah, hold on.
Who wants more live review pre-AP exam though? What units do you think we should live review before the AP exam?
Simple
I-
harmonic motion.
yes.
Yes.
Um, the hard mech ones, and then like
The calc
beginning.
or the
Uh,
calculus stuff.
Okay, so I don't know how many review sessions I'll be able to hold just because like I have a life as well.
sorry.
Uh, But I think we're gonna do one, which is just every single physics C differential equation. Just every single one. Probably like a 2 hours video session. And then
2 hours?
another one that's probably gonna be, I think Unit 6 is the most requested one. Um Unit 6 is definitely an important unit to know for the mechanics exam. So
Which one is six?
simple harmonic motion.
Sigma.
So here's why. You choose a direction, right?
Yeah.
And let's say I want to choose this direction. The So any voltage that's in the same direction as the loop is positive. Any voltage in the opposite direction of the loop is negative. This is why, because this is the opposite direction of the loop, it's negative V of L. And because it's in the direction of the loop, it's positive V of C.
Oh,
This is true. Because basically, I'm just going to be taking questions and like requests now for the rest of the time, probably until 9:30. So, any requests?
wait, so but then if you have wait, okay, I'm gonna draw. Like if you have
If I have what?
hold on, wait, can you see my drawing?
Yes.
Okay. So if you have this, right, then like you would write the Kirchhoff loop rule thing as um IR plus L di dt. So wait, because in this case, like for this one below, you're treating it like your capacitor is like the voltage source, right? So your voltage source is like adding to
Not
your
exactly. I'm just because a battery can also be negative, right?
yeah.
So I'm just treating it as a loop. My loop is this way. So anything that has a voltage that way is positive, and anything that has a voltage the other way is negative.
Oh, okay. And then the negative L di dt is just like the inherent like definition of the potential difference for the inductor. So it's always gonna like you're always gonna plug in negative L di over dt. Like this one.
Yeah, it's always going to be negative. That's just the definition of how the inductor works.
Okay.
But also, the thing is, the inductor always opposes the direction, and so that's why the extra negative sign is added. So they add ding. Alan,
Okay.
you have any questions you'd want me to go over? Raina, any questions you want me to go over? Is it? No, okay, number 13, page 19 of the freaking packet, yo. So, page 19? leave.
Wait, so okay, can we quickly go back to the question I was at before?
Zena, I'm just drawing a circle, and if it follows the circle, it's positive. If it goes against the circle, it's negative.
No, 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 but wait, okay, hold on,
I have spoken.
please. Okay, wait, so but like for this other circuit that I drew, if you like still plug in the negative L di over dt, like you don't, the
There's
signs
no
don't,
there's no positive end to an inductor.
there isn't. Oh my God, I swear, I
There's
literally
no
just,
positive end to a resistor. There's no positive end to an
okay,
inductor.
no, no, I'm just like being hypothetical here, okay? Whatever. So, but the direction of voltage is this way, like the potential difference in this
This is this
inductor.
way.
Yeah, but the direction of the potential difference, like for the inductor, it'll be this way,
Yeah.
like
So
opposing.
E minus
Minus delta V, minus the potential difference across the resistor, minus the potential difference across the inductor is zero, right?
yeah.
But then if you do, like, that doesn't match with this one, because if you move it on the other side, this term would be negative. If you just,
This is a positive. This is gonna have initially no current. Zero. I'm
uh-huh.
just gonna ignore that. And then this creates its own
What's
current.
up?
Goes the
Yeah.
op other way.
Wait, okay. So, but like in terms of the equation, you did epsilon minus negative L di dt, right?
Yeah.
But I was looking at like I guess the answer or whatever you can call it. Like they did like fine for the final ones, epsilon equals IR plus.
Yeah, you because
Like
those two add up to be equal to the voltage. You just want them to add up to be equal to the voltage.
okay.
Hear me out. Draw
It's
a
just
circle. Whatever makes sense is the signs.
okay. I guess the
I have
only
spoken. We are doing number 13 now. Okay, so power is everything. So REQ 12, 6, 4, 14. So then we go, I got this way, that's I equals to 3 amps. So the voltage drop across this is 30 amps. So there's 12 volts, 12 volts. And so I is equal to 1 amp, and we have 2 amps. And so P equals or equal to V squared over R. And so this is like 90 watts. This is like 144 over 12. That's equal to 12 watts. And that's equal to uh, 144 over 6, 12 to 24 watts. So it's there.
So brightness is going to be power.
Mhm. That's why you have like a 50-watt light bulb or a 10-watt light bulb.
This makes sense.
This is true.
This is true.
42 volts. T equals 0. IA, IB, IC. Immediately after the switch is closed. So we're going to have nothing flows through here. C equals to 0. IB equals to IA equals to 42 over 22. This is true. And so after a long time after the switch is closed, this goes back to not being important, and so it goes back to whatever it was before. And so we go back to IA equals to 3 amps, IB equals 1 amp, IC equals.
This might be true.
This is true.
This is true.
Chat.
There's the next page.
There's another page of the packet, yo.
Friggin' packet, bro.
Packet PMO.
TSVMO, bro. I think you forgot the P.
So such magnitude across the inductor as a function of time. So we're gonna go like bam. And
Makes sense.
then capacitor. We go like bam.
Okay, thank you.
Simple as. Group leader speaking. Chat is saying page 24. Who's breathing absolutely deviously loudly into the screen?
That's my computer.
Okay, Ben.
Not a computer, bro.
Can you still hear it now?
No. This is good.
Okay, I don't know what to tell you, bro.
Thank you. Yeah, the total energy, because initial energy is so all the energy is dissipated. Simple as. Part 23, Part D. Zena, what do you need help with?
Wait. When you have a moment, can we go back to my
No.
But the thing you wrote doesn't match. Like the signs are not what the answers have.
Signs are just like ideas. They're concepts. You
No,
What
just
I
about,
you
I
just
get
you just throw signs at the problem until you get it right.
what
I
about
thought that
cosines?
that's wait,
This is
what?
true. So page 23, Part D. Total energy. So P. So so integral of power respect to time equals to the energy dissipated from 0 to infinity. And P equals uh so I we have this, right? So we have I squared R. So it's 0.18 times -8 times e to the -4t squared over R integrated from 0 to about infinity dt. Once you do that, that gives you P.
TTM.
This is true. What is the chat saying next? FRQ number 3 after Alan finishes dinner. Sounds good. So Xena, we are back to TS question. So in this question, this is our positive. Let's use the pinkity trinkety. This is our negative. So here, voltage and resistor. So E minus V of R, because you always lose energy across a resistor, and then plus
Wait, so epsilon is equal to negative L di dt minus IR? Oh,
we get that. Simple as.
yeah. Yeah.
Makes sense? Because resistors always dissipate. Capacitors add.
Oh, okay.
Simple as. I've spoken.
Okay. And then wait, so in this like AP classroom screenshot thing, is it because they told you that the direction of the potential difference is like this way?
It's
Or
pretty, it's gonna be obvious because the inductor's gonna have
the
the
opposite?
opposite. The opposite, yeah.
Okay.
Because E equals to 0 because there's no actual voltage source.
Yeah. Okay.
Any other questions from group? E to the negative infinity is 0 and e to the 0 is 1. This is true, Randall Parker. Michael Who has joined the chat.
Hello.
What is up, Michael Who? Do you have any problems you discussed?
Not right now, no.
So do you guys want to do subs? Potential difference across. I mean, we can do part FRQ number 3. Where is FRQ number 3?
It's in the freaking packet, yeah.
Yeah, no, ever knows that, Ben.
Well, I didn't really know what you were asking, so.
PMO. PMO.
If I had to guess, it's after FRQ2.
This
There
is
we
true.
go. There we go. Good job.
Experiment 1 switches close to position S1 at time T1 left there for a long time. S1. So And for the second part, the second part is looking simple as so far. So let's see how the second part does.
Wait, why is there a line? A horizontal line until
Because
T1?
until T1, it does not there's no charge because the switch isn't on
Oh,
thing.
yeah.
Maximum current. So I'm assuming that the top part says the switch is now closed. Yeah. So
Could you go back to part A, number 3?
right after, yeah.
Yeah.
So
Just
0.22 joules equals 1/2 L.
$25 millifarads.
So 0.22 equals to 1/2.
Wait, where do you get 0.22 from?
The first part.
But for V?
Yeah, for E of the capacitor.
It gives you the capacitance. But
Yeah, I'm just not writing all that.
okay. It
Equals
would have been a lot shorter, but
capacitance is
25 millifarads.
so minus 2, 25, 0.25 square root of. What's the inductance?
I mean, the inductance is 5 henries, I believe. Ding. I don't know where the square root part is from, but I just got like 2
Plus
volts.
4 is 20, 20, 22, 2, 2, 4.
I think it's just 2/5.
Like C is like
Wait, where do you get the square root from? I don't think you have to do anything energy related.
how did you do it?
I just found the voltage using the charge and the capacitance. And then once I had the voltage, I just did EMF equals L d I dt. Is that wrong?
Yeah, you can do that way as well. You can do it like either through energy or the voltage equals to 0. So it's either like CV, so like CV equals LI, or you can do the other way, yeah. This is completely true. So, so not CV, but Q over C. Q over CL.
Wait, but how do you know that the voltage of the capacitor equals the voltage of the, or across the, or the induced voltage of the inductor? Does that question make sense?
Not exactly. Could you repeat that for the?
Okay, so what I did was voltage equals Q over C
Yeah,
equals L di dt, or
yeah, that
negative
makes
L.
sense. That makes sense. Perfect
But
sense.
how do you know that those two, like the voltage across the capacitor is equal to the induced EMF?
So we're gonna go back up here
Uh-huh.
and we're gonna read Kirchhoff's loop rule.
Oh, I'm stupid. You're right.
No, this is good. You're good. You're good. Um, just 8 minutes. Any questions? FRQ number 1, part D. For the rest of the time, I'm gonna probably stop the recording after the next part. We're gonna do something group speaking. I don't know. Oops. So FRQ number 1. This freaking square, yo. So flux. Did that. German expression from the current goes in top loop for time t. So I. And you divide by 6. 0.3, 0.12. Yeah, that makes complete sense. Yeah, that's right. And then just take the. So, like, there. Okay, so recording will be